Okay, so let's continue with our coding exercise series. So open the leetcode.com and go to the problems tab. And in the search question number 200. So the question is number of islands, which is the medium category. Click on it. So let's read the question. So given a M cross and 2D binary grid. So we have grid means like we have some matrix is given. M cross and means like number of rows and number of columns, which represent a map of 1 and 0. So the matrix contains only 1 and 0, where 1 is a land and 0 is a water. Return the number of islands. So we need to return some number. So it means we need to return some integer. So if you see the function signature, we need to return some integer. And if you see, we have given means some argument has been passed. So if you see a grid has been passed and a matrix is a list of list. So a list of list is passed, right? And one thing to notice is, so even though they have mentioned this matrix contains 1 and 0. So generally 1 and 0 are integer, but 1 and 0 are in a form of a string. So if you see, there are double quotes around it. That's why it is mentioned list of string. Okay. Now we need to find the number of island. So what is an island? So the next definition is this. An island is surrounded by water. So generally in island in geographical terms, is island is that area of land which is surrounded by water, right? And it is formed by connecting adjacent land horizontally or vertically. You may assume all four edges of the grid which are surrounded by water. So let's directly jump into the our dashboard. So this is one example. So look at this example. So this example. So we have some matrices given. So we have like some rows and some columns are given, and we have one and zeros are given. So we need to find how many islands are exist. So like to check the, so island is so island is a part of a land basically, right? So island is a part of a land, and land is represented by 1. So we need to calculate, we need to find the land basically, right? So if we start from here, right? So this is a matrix, and how to scan the matrix by running two for loops, right? So one for loop on rows, one for loop on columns. Okay, so we start from the first element. So we found 1. We found 1. So 1 means 1 is a land, and we can say, okay, it could be an island, right? It could be an island, it could be surrounded by the water, right? But like when there is a land, so this is a land, let's suppose this is a land, and this is a this, and it is surrounding by some water, right? So we will start from here, but we will call this as an island, or we will call this whole as an island, right? So we will call this whole as an island. So that's why we need to find, like as soon as we found the number 1. One second. As soon as we found the number 1, we can't say that this is an island. Definitely this is an island, but we need to find the whole area of island. And the whole area of island means the one which is connected by the 1. That is the land. So as soon as we reached here, using the first for loops, the first index is this one. So we need to check is adjacent. And how to check the adjacent? We need to check only horizontally and vertically. Horizontally and vertically means we will check here, we will check here, we will check this side, and we will check above side. So this side there is nothing, this side there is nothing, or we can consider as a water. So this side we have the land, and this side we have a land. So now we have the land. Now we will check the adjacent of this. So we found again land. Then we will check adjacent of this. We found again land. We will check like below there is a water, so we will ignore. We will check below there is a land. So when we reach here, we will check this. Then we will check this. Then we will come here. Then we will come here. So basically, this whole area is a this whole area is a one island, because after that there is no one, after that there is no one, so output is 1 because there is a one island. Just forget about the logic, just think about from the figure perspective. Like if we have the figure is given and we don't know to write the logic, how to find the number of island. So this is the number of island. Let's look at the second example. So if we start from this, so we need to find the whole land means all connecting ones. All right, so all connecting ones. So we start from here. So this one is connected with this, and is this one connected with one? No. So is this connected with one this, and this connected with one this? All right. And now you can say this connected with this one as well, right? and this diagonal. But in the question it is mentioned to we need to like see the land which is connected either horizontally or vertically. So diagonal is not considered here. So that's why this diagonal is not considered here. All right. So this diagonal is not considered here. So this is one land. So this is one land. This is one land. So we found one land, and rest of the definitely is a water. So we because if there is a one, then we will also consider that part. So this is one land, right? So one island definitely is there. So let's check other. So this is zero. This is zero. This is zero. So no island. This is zero. No island. This is zero. No island. So this is zero. One second. Let me take a marker. So this is zero. This is zero. This is zero. What is happening? All right. So this is zero. This is zero. 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 Now we found one. One means it means land. But is this the only land or is it a very big land? So let's check. So when we find one, we will check it adjacent. There is a like we will check horizontally and vertically. So there is zero, there is zero, there is zero, and there is zero. So it means only this one. So now we have one plus one, two. One plus one, two island. Alright, then we will check next zero, then we will check next zero, then zero, then zero, zero, zero. Then we found one. But is this the only island? Or we will check adjacent. So we found adjacent. Now we find the one island, one more island. All right. So one plus one, then plus one more. All right. And we found total number of three island. Total number of three island. So this is what we did by just like looking at the image. But how we are doing it actually by using the coding. So by looking at the coding, what we are actually doing by looking at the picture, what we are doing is we are first thing is we are scanning the matrix. So how to scan the matrix by running two for loop. All right. So let's jump into the code section. So we are scanning by running two for loop, and to run the for loop, we need to know the number of rows and the number of columns. So let's find the number of rows. So how many number of rows? How to calculate the number of rows? That is the length of the matrix. That is the length of the grid. So length of the grid. All right. And how to find the number of columns? Column is like the it is a list of lists. So the first list and the length of the first list. So length of grid of the first list, right? So we found the number of rows and the number of columns. Okay, and we need to return the number of island because we are adding some output. So let's take some element, some variable number of islands, and initially it's zero, right? Now we need to run a for loop. Okay, so for I in a range of rows, for j in range of columns. Okay, so this is what we are doing, right? And then what next we are doing? So we are checking, did we found one or not? All right. So how to check if there is a one? If grid of I and j equal to one, and as I told you, it is a string. It is a string. So we need to put it the double quotes. Okay, we are checking if it is a one or not. If it is a one, if it is a one, then what we are doing? Are we like directly making our output as a one? As soon as we found one, definitely there is a one island. So definitely there is a one island. So number of islands plus equal to one. Definitely there is a one island. But how much big is that island? How much big is that island? We need to check that. We found one island, but if we just mark it as a one, then it means this island is another island, this island is another island, this island is another island. No, but this is a one island. So we need to check is adjacent. So how to check adjacent? So we are going like north, south, east, and west direction, basically four direction, right? Horizontal and vertically. So we need to check its four direction because currently we are on this element, only on this element, and we need to check its neighbor, right? So neighbor, we need to check its neighbor. So let's create one second. Let me rub this. So currently, one second. Currently, we are on this, and we have to check its neighbor. So let's. So as soon as we found one. We have to check its. We have to check the current island. how much big is island. So check current island. We need to check some current island. And so there is some different function. Let's create a different function. Def check current island. All right. So this is a different function. We will come. Just forget about the logic. So this is some different function, and we need to check is its adjacent. Its adjacent. How to check its adjacent? We need to pass. Okay, on which index we are. So we are passing on which index we are. Only then we are checking its adjacent by adding +1 or -1, right? So this will take some two argument, row and column. On which row and column it is. Okay, so it is taking two argument, row and column, which is fine. Okay, now what we have to do? We have to we have to like so this is we what we have to do. We have to go right hand side. We have to go left hand side. We have to go up and we have to go here. Right. So we have to do uh, so this is a row. So we have to do row +1, and we have to do row is equal to row -1. So this is the column. We have to do column is equal to column +1 and column is equal to column -1 for the same row. Right. So so we have to check the current island. We have to check the current island by same row and column +1. And we have to check the current island same row and by like column -1. So column +1 means like you can say right side. Column -1 means you can say left side. Okay. Now row +1, row plus one and same column means row +1 means we are checking downwards. It means downside, bottom. All right. And then we are checking row -1. Row -1 means like so this is the current row. -1 means the above row, right? So it means we are checking top side. Okay, which is perfectly fine. Okay. Now what will happen? What will happen now? If you see what will happen. So what will happen? So we are currently here. We are currently here. Now we call the same function, and by passing row, so the same row because I is equal to 0 and j is equal to also 0. So we pass 0. So we pass 0 and we pass a column +1. Column +1 means 0 + 1, 1. So we pass 0 + 1. So we have some element here. We have some element here, which is fine, right? And then we are calling the same function again. We are calling the same function again. So now just forget about the same function again. And we are calling row, and we are calling row means like row is equal to 0 and column -1. 0 -1 means we are calling -1. We are calling -1. So this is going to be fail. This is going to be fail. So before checking, we have to put some if condition for the boundary walls. So the boundary walls. So if row less than 0, because this is our 0, this is our 0 row, this is our 1 row, this is 2, this is 3, right? So if row less than 0, then we are not going to check these things. We will just continue, right? So we are going to just return. We are going to just because we are calling this function, so we are going to just return, right? So row less than 0 or row greater than equal to rows. Maybe once we reach here, so it is like proceed when we reach here, row is equal to row +1, right? Same for column less than 0 or column greater than equal to columns, because it will come here, right? And it will come here. So column if less than 0, or if it is 0, if it is 0, do we need to check? No, because we are checking only one. We are checking only adjacent one, because if it is 0, we are not going further. Right? If or grid of row and column equal to 0. If it is 0, then what we are going to do? We are just returning. We are just returning. Now, one more thing, but one more condition we need to add. What was the condition? Now you see, once we are here, what is its adjacent? We are checking here. We are checking here. As soon as we go above, this condition did not match, so it's return. As soon as we go this side, this condition did not match, so we return. But when we go here, but as soon as it come here, it come here for this. One second. As soon as we come on the second row, so this row, no, on the second column, this column, we are again checking its adjacent. So we are checking this side, which is fine. Again we are checking this. Again we are checking this. So which is wrong, because we already checked this element. Why we are checking again? So it means as soon as we check particular one element, we need to store in some set kind of visited array. So that's why we will take some set visited, and we will take a set. All right. So we already visited I and j. We already visited I and j. So we will mark them visited. Visited dot add. We will add I and j. All right. Along with that, so if the element is visited, do we need to check? No. So we will check or row column in visited. If it is in visited, then we are not going to check. Right? Then we are going to return. Along with that, we are running a for loop. We are running a for loop. So we already check its adjacent matrix, and we already check what are the land, what are all the lands. All right. So now for the second for loop, when the second for loop come, we are checking for this element. But do we need to check this element? No, because we already check as part of the first element. This is part of the previous land only. So when we are checking, we will put some condition here, and I comma j not in visited. All right. So if it is not in visited, then only we are going to check. And at the end, we are going to return number of islands. All right. So what we are doing is what we are doing is so by looking at the graph, how you are finding. So you come here, then we are checking is adjacent land. Okay, but all the adjacent land, and how you are checking adjacent land? By checking all the ones. And as soon as you checking it, right, so you have to make sure you should not check again and again, right? So either you mark it as a 0, make it as a water, or make it as a 2 by some other number, or store it as some listed. So I am storing it somewhere, even though it is taking some memory. If I assign it as a 0, then it is not, then we can save some memory. But just for the timing, let's take some extra memory, right? So that's why we are running a for loop to scan all the elements. We check it's one, all right, and then we are checking the current island. Okay, we found one, but what is the current island? What is the full island? All right. So for the full island, we have to check right, left, bottom, and top. And the current element we will mark as a visited, so that we should not check again and again. All right. And we will check the boundary condition. All right. So when it return by marking everything as a visited, so everything as a visited, it mark as return, then we are increasing the number of island is equal to one. When it's reach here, so in this case, let's see this case, we are here. So we will check this, and we will come here. So it is 0. It is 0. So we are not going to check. We will check this. We will check this. So we will found one island, and we will come here and we will increase. Now we will uh, now we will go here. So will it go inside the for loop? No, because it is not zero, it is not one. We will go here, 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 for loop will go here, then for loop will go here. So we found one. And is this element is visited? No, this element is not visited, because when we check here, we are checking this side, this side, this side, and this side. So this element is not visited. So we will check. Now we will check, is this the only land, or is there is a very big land? So for this, we will check this, we will check this, we will check this, and we will check this. We will not find anything. We will, and if we found anything, we are just marking and then increase the number of island. Then we will check next element. Next is 0 0 0 0 0. Then we found one. Then we found one. But is it the only land? And is this visited? No, this is not visited element. So if this is not visited, okay, is this the only part of land, or is the very big land? So let's check its adjacent. So this is adjacent matrix, we mark as a visited. Why we are marking as a visited? So we will not uh, treat as again and different land. That's why we are marking as a visited. So we were marked as a visited, and that's it. And this is the one more land. So the output is 3. So let's try to run our code if there is any issue or not. So something is wrong. So it is saying maximum recursion depth, maximum recursion depth. So something is wrong. So it's not ij, it's row and column. That's why we are marking as a like visited, because that's why it's come a maximum recursion. Because if we not mark as a visited, it is just checking again and again the same element. So now sample case has been accepted. Let's try to submit. So our solution has been accepted, and our solution has been accepted. And if you see the memory, we beat only 8% of the person, which is which we understand, like why we consume so much memory, because we are using some extra memory here, right? So if you don't want to use this extra memory now, if you don't want to use this extra memory, you can remove this. You can definitely remove this. And what you can do is, as soon as you found one now, as soon as you found one, what we are doing is we are marking as a visited, marking as a visited. You mark it as a zero. You mark it as a zero. Because if you mark it as a zero, you are not going to check again, right? Because if you mark it as a zero, you are not going to check again. So by that way, you can save like even more memory, right? So that's it. That's the end of the video. So you can also try this question. This is like a good question and mostly asked in the interview. So thank you.